Hi everybody, I would like to welcome you. My name is Olenjolai from Tanzania. I would like to welcome you onto session 5 of organic chemistry. We have our online school that called the Advanced Online called Tanzania Online Advanced Secondary Schools in Square Bracket OLENJOLAIM, and we have our YouTube channels that called Tanzania Online A-Level Secondary Schools which we used to upload many videos of 3 departments: advanced physics, advanced chemistry, and advanced mathematics. So I don't want to waste much of your time, but I left in session 4 of organic chemistry, which was, I told you about isomerism. I left 2 questions for the homework. And then I want just to do the correction. Start with corrections, then I'll teach you about the concepts I've written there, bond breakings in organic chemistry. So let us say correction. So you have to check whether you are right or you're not right. Correction of homework, because this is the foundations of entire organic chemistry. Homework 04, we had question number 1 and question number 2. However, that I won't give you all the information, but I will give you the ABCD. The first question was stating that with aid of 40 examples, describe briefly the meanings of positional isomerism. Right? Isn't it? Hopeful. So let us start with solution of example, don't remember exactly that, but of question 1. And that read like that with aid of what? With aid of examples, right? Okay, explain briefly the meanings of positional isomerism, right? So we'll explain the meanings and then I'll give you some examples. Simply the meaning of that question is, first of all, you have to define what is positional isomerism. To mean that in your brief instructions, you have to include this. What is positional isomerism? Okay? So positional isomerism we say that is the tendency of organic compound, right? Organic compound to exist in the same molecular formulas. Guys, I'm teaching you. Seem like you are waiting for the bus, for the school bus. Same molecular formula, but different position of 40 of substituent group. So we say that molecular formula, but different position of 40 substituent group or functional group of the compound. So positional isomerism, it can be formed in 2 ways. Whether by changing the positions of substituent group or by changing the positions of the functional group. So types of 40, we say that so we say that first of all, we say that positional isomerism, okay, due to change in position, you're not writing, of 40 of functional group. So straightforward examples can formulate this in this way. For example, you can have CH3, CH2, CH, and CH2. So if you write open structure of this compound, it's carbon, 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 double bond. I left my homework that how many pi bonds are there in alkynes and how many sigma bonds are there and why. So then here we have two hydrogens, So here you have one hydrogen. So the way that we name these compounds, we number it from here, 1, 2, 3, 4. So this we call T but hyphen, hence in the first carbon we have our functional group. So how do we formulate positional isomer, right? So you say that the same compounds, we can write it, but we change the positions of the functional group. The functional groups of alkene is double bond, of alkene, it's double bond. So simply, here we have hydrogens, this is sigma bond, then this is sigma bond, sigma bond, sigma bond, sigma bond, sigma bond. So even this is structure, so you don't have here. Even this is structure. So this is still butane, but the position we have changed the positions of 40 of double bond. This is 1, 2, 3, 4. Okay? So with this one we say that this is but. Okay, then we say 32 and so even the nomenclature is quite different. So that's what we call T. You have the same molecular formula. You sure you're not writing, you're just smiling and doing nothing. So 4 carbons and then so you have what? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 hydrogens. Similarly here the molecular formula is 1, 2, 3, 4, 5, 6, 7, 8. So 4 carbons and 8 hydrogens. So same molecular formula but different position or different positions of the functional group. Then secondly, if you have the substituent group right now, then formulate position isomerism to the position of positions of substituent group. Okay, but I can give you some more examples. Okay, so for instance, also you have CH3, you have CH2, you have CH2 OH. This is propanol, right? So propanols, the OH group is on the first T. So this is called propan -1-O, right? So then we can formulate another isomer or an isomer by CH3, then here we have OH. These are the simple isomers, right? CH3. So you see that now the positions of 40 functional group, it has changed. So this one now we call the propan 2N, terms of nomenclature. But this one we call the propan. So same propan, same molecular formula, but different position of the formula. Then we say that you can formulate by using substituent group. Okay? So you can formulate this one, organic compounds with the different substituent group. How we may do it. For instance, let's say that we have CH3, we have CH2, we have CH2, we have CH2OH. So this is a straight chain. This is straight chain, so you can also write that this is H3, then you have CH, then you have methyl here. And then, if that's the case, you have CH2OH. How many carbons? You have 4 carbons here. How many hydrogens? We have 6, 9, 10. How many carbons? We have 4 carbons. How many hydrogens? We have 7, 10. But this now, it has substituent group, while this one does not have substituent group. So for instance, this one we call it butanol. We don't write that -1 or Okay? And then this one now, okay, we number from here 1, 2, 3. So this is the substantive group. Or 1, 2, 3. We have two alternatives. Right? And hence our tertiary group is what is methyl. So 2 what methyl, what methyl butanol. So that's all about 30 positional isomerism. So at least it's also a piece of information that I expected you to write to me in the comment sections. Unfortunately, until I'm recording this lecture, no any students who have replied or submit his or her homework in the comment section. Then we had the second question. The second question was read with 8 of examples. It's 8 of examples. Explain the meaning of 40. Explain briefly the meanings of stereo isomerism. So simply the first question that you have to answer in that question, what is stereo? What is stereoisomerism? So stereoisomerism we say that is a tendency of organic compounds to have or to have the same molecular formula, but different what? Different, we call it different, same molecular formula, but different spectral arrangement of their atoms, called the configuration. Different spectral arrangement of the atoms, called the configuration. Called what? Configuration. That's the meanings of one of the definition of what stereoisomerism. Well, some of the resources they used to say that these stereo compounds they differ in three-dimensional. Okay? So one of the definitions, yes, I accept it. But how do they differ? So we say that you have to say that differ in spectral arrangement of the atoms called configurations. Types of stereoisomerism. That's what this is the second piece of information that you have to explain to me. Types of stereoisomerism. Types of stereoisomerism. There are two types of stereoisomerism. Two types of stereoisomerism. That are, the first one is called geometrical isomerism. And that's what I'm going to discuss this lately. And the second one is optical, means light isomerism. So here geometric isomerism and optical isomerism. In these sessions or in this subject, we're going to cover about geometrical isomerism. So another piece of information that I expected you to submit to me is what is geometric isomerism. What is geometrical isomerism? is geometrical isomerism? Form 1 of the definition. So we say that these are the isomers. These are the isomers that exist. That exist. Okay, that exist only when is at least one bond in a molecule. Around the adjacent atoms. Around adjacent atoms. Around the adjacent atoms cannot rotate. Around adjacent atoms cannot rotate. Give you further information about that. You said that the stereoisomers exist as cis and D trans. So stereoisomers exist in form of cis and dirty and trans. So you say that these are the isomers that exist only, so they do exist only, when at least one bond, not all bonds, in a molecule around the adjacent atoms cannot rotate. So it means that atoms, they have a tendency of rotating. And they form the geometrical if that the atoms surrounding that compounds are not rotating. Right? That's the meaning. When you say that the geometric isomers exist in cis and trans, we say that this is the example. We have what? We have, for instance, alkane or ecene. And then we say that we find these carbons, let's take also a substantive group called the X. And this one take X. And this one take Y. And this one take Y. So because these substantive groups have lines along the horizontal part, this we call the cis. So this nomenclature called the cis what? Cis isomers. Cis isomers. cis isomers. Cis isomers. Okay? So this is cis isomers. And then if you have carbon, for instance, that we have double bond again, then here we have 1, and here we have 1. Here you have X, and here we have X. This in chemistry, we call it trans isomers. Regardless of which example is. Okay? Example, this is a trans isomer, for instance, you have carbon, and then you have double bond here. Okay, so you say that this is methyl, and then okay, so we can have it in CH3, it's fine. And then she said that here we have hydrogens, and here we have hydrogens, and here we have methyl. So in this case, we say that, you see, so hydrogen, hydrogen, methyl, methyl. So this is called trans. So this is called the trans. Trans but hyphen what? But hyphen 1 N. Right? All together. So this one also, that is trans. We can change the position. So this becomes as hydrogen. This becomes as goma. Okay, goma here. So this goma is C3 and C3. So this we call it cis. But here we have again methyl cis. But even this one called cis. But here we have a methyl group. Cis hyphen. And then we say that what 2 methyl group. Right? All together. So this we got cis. And we have what? Cis 2 methyl. Methyl but 1N. Right? So those are the examples of 40 geometrical isomers. So I would like again to leave a simplest homework for you because you're going through that question. You can do now the question number 2, which is explaining about the issues. Now let us go to another conditions of learning organic. And this is today, it is number 3, called bond breaking. Body breakings and formations, but the main concentration is bond breaking. Showing your mind there. Bond breaking. Organic chemistry. Bond breaking mechanism. Bond breaking mechanism. we say that when organic compounds react with another organic or non-organic compounds, then we expect a new product to be formed, right? So what do you say? So we say that you have one of this type, which is called the bond breaking mechanism. One thing which I want to let you know about breaking bonds, we haven't learned it a lot. But really we are breaking our financial life. So we're breaking our financial life, but you can break a certain piece of the problems inside. Excuse me. So you say that the concept is, we've been learning about maybe organic compounds, reactivities, been learning about nucleophile, electrophile, free radicals. You see? So you say that we are really interested on reactions. So in advanced organic chemistry, we teach students some rules, which I'll teach you in the next session. Some rules of following when you are making a follow-up of everything that you have seen there. Okay? So you have the first, you can say bond breaking mechanism, or you call it bond efficiency in some of the books. So you have a question. So we are not going just to teach about the types of bond or whatever. No. The thing that we are going to do here, we are going to teach you mechanism. Steps that you have to follow when you want to prepare certain compounds from another compound are the main that you are going to learn. So the fundamental question what is bond breaking? What is bond breaking in organic chemistry? Well, there are several definitions. So simply we say that it's a process that takes place so it says the process that takes place when the organic compounds combine or break the combine to form the new bond formation. So we say that the bond breaking is the process that takes place when the organic compounds combines or reacting with another. With another form, to form what? So then to combine to form the new bond. From the new bond. Okay? That means of 40. So you say that when the organic compounds combines with another come to form a new bond. So you say that when organic compounds organic compounds reacted together. When the organic compounds undergo chemical reaction, RHN chemical reaction, there is bond breaking, and what? Bond formation. So simply, what are we going to sing at the song? Breaking bond, forming bond. Breaking bond, forming bond. Okay? When you say about mechanism, it means that we'll be teaching you steps that you have to follow in case of breaking bonds. But that ones we'll be discussing in details in session 6 when we'll be teaching the rules of breaking and forming bonds. So we say that bonding, breaking is also known as bond cleavage. Bond cleavage. So we hear about bond cleavage means bond breaking. Types of what? Of bond breaking. So you said types of bond breaking or types of bond cleavage. So you say that in organic chemistry. There are two types. Two types of bond cleavage. Bond cleavage. There are two types of bond cleavage. The first one, we call it homolytic. Homolytic bond cleavage. Homolytic bond cleavage. The first type. And the second type, we call it heterolytic. Heterolytic. So the second type we call it heterolytic. Heterolytic bond cleavage. Homolytic bond cleavage and heterolytic bond cleavage. Homo means one. So if you know homo means one, so what is homolytic bond cleavage? Yes. I think that one of the students who is watching this video, his or her answer is one. So homolytic bond cleavage is one. So let us start with this. After we are not going into too much details of these two types. Number one, homolytic. Homolytic bond cleavage. Homolytic bond cleavage. homolytic bond cleavage. This is R. And the fundamental question is, what is homolytic bond cleavage? What is homolytic bond cleavage? Right? So homolytic bond cleavage, before even just write it there, what's going on here? Remember that when we are forming a new bond, we can form a new bonds between part of organic compounds and the part of inorganic compound. Right? Or you can break maybe the bonds which exist within the organic compounds, but also their substrate groups, which is what we call attached group. So the means of homolytic bond cleavage, we say that is the types of the bond cleavage in which that one of the atom that has formed a covalent bond, right, to form a molecule, leaves with this means that homolytic bond cleavage, we say that this is the types of the bond cleavage or bond breaking in which that each atom will leave its electrons that has contributed in formations of what? Covalent bond. That's the meaning. Let me write. Let's play. So this you say that is the type. It's the type of bond. Breaking bond. The type of breaking bond. Type of breaking bond in which each atom in which each atom leaves with its electrons, leaves with its electrons. Leaves with its electrons. So we say that this is the case of bond breaking, in which each atom leaves with its electrons. What does it mean? We'll give you a simple example before we write a reaction. So the type of bond of broken bonds in which each atom leaves with its electrons that are contributed during the formation of covalent bond. So what we say here, for instance, you have chlorine atom, and also you have chlorine molecule. So then again you have, for example, hydrogen, etc. Simplest and first elements in the periodic table. Right? So what happens? So this is chlorine atoms, is chlorine ion, not chlorine molecule. So you say that I want this is chlorine molecule. Okay. So this is chlorine molecule, so what you say. Before, if you remember that, the electronic configurations of chlorine is what? The configurations of chlorine atoms. So if you are using the oldest style, say 2H7, right? So the valence electrons are 7. So to formulate chlorine molecules, this should add up 1 electrons in the valence shells, which will make it 8. Right? Are we together? So if you write the electronic configuration, for example, for this molecule, yeah, it's going to be a challenge. But you've got the point. Right? So if you write in this, so this is neon. So 10 remains 7. So this is possibly 3S, 3P. So here remains 7, so we have 5. Okay, so this is the electron configurations of 40 of chlorine. But now you have chlorine molecules, so it has gained one, it has shared one electron to another one. So this is 6. So it's already now not in octet state. So what happens? So it means that to have chlorine, if you take chlorine plus chlorine, we get chlorine molecules. Now we want to break the bonds between chlorine and chlorine. So first of all, the chlorine molecules, is it formed by the same compound or what? Eh? So you say that now, because there is a reaction called chlorination. We take chlorine and reacts hydrocarbons or aromatic hydrocarbons, right? So you say that if, for instance, because chlorine exists always in molecule, okay, so this is chlorine molecule, right? And this is the covalent bond. This is covalent bond. How this covalent bond is formed? This chlorine contributed 1 electron, and this one contributes 1 electron. So because they are sharing 2 electrons, this is the octet state and this is the octet state, right? If you now want to break the bonds, then this is the symbol. This is in case that chlorine will take some few electrons, right? All together. And then again, this chlorine, when it has formed this bond, it had its own 7 electrons, even this one similar. So this kind of half arrow, that's what we say, that each atom that has participated in the formation of the bond is going to leave with its electrons. So this one is going to leave with its electrons, and this one is going to leave with its electrons. So then now we have chlorine, and also we have chlorine. But this also we call them free radical. Are we together? Are we together, or you are just trying to end the session? This chlorinity, free. So this is a free radical and this is a free radical, right? And then this one, remember that we formulated this after this bond breaking. This we call it homolytic because first of all we are breaking a bond between the 2 atoms which of the same element. Again, when after the bond breaks, each atom is going to leave with its electrons that has contributed in formation of covalent bond. Are we together? So if that's the case, we say that examples, if you have understood. Similar to bromine, we have several of them, so you have to watch. So examples, we have chlorine, free radical, we have bromine, free radical, you have what? Fluorine, free radical, then you have what? So this is free radical, free radical, free radical. And then again we have what? So this is all about the homolytic bonding cleavage. We need those free radicals to react with some other elements so that we can enjoy. But again, you can formulate another free radical in methane, where you can have bonding cleavage, multi-bond cleavage in methane. Methane carries 1 carbon, but how many hydrogens? 4 hydrogens, right? So how will it undergo this homolytic bond cleavage? And then this guy, and then this guy. Okay. So it is the case, we say that we want to break the bonds, that the bonds between carbon and hydrogen here, right? So I want to break one of them. So because of the nearly electronegative, you find that carbons will leave with its electrons that has contributed, and also that hydrogens will leave its electrons that has contributed, right? All together. So this side, which has received just equal to partial negative, does not a great matter. All right. Are we together? Okay. No. Huh? If not, just ask me. I say that. Let me repeat. Let me repeat this part. We have methane, one of organic compound. Before reaction, this is methane. Listen carefully. You have to understand this because otherwise you'll get lost when we continue with organic. So carbon contains 6 hydrogen. When we write this advanced electronic configuration, this is helium, and then say what, 2s, if I'm not mistaken, 2s what, s2, and then say 2p. So you have 4 minus 2, it is 2. Right? Simply, this is the tetravalent element. So what do you say again? Hydrogen, it contains only 1 electron. It might contain or it might not contain. Right? So now carbon and hydrogen is missing 1 electron, carbon is missing 4 electrons. We form a covalent bond between this carbon and hydrogen. Okay. So this is covalent bond, right? So remember that to form this bond, hydrogen draws its electrons, 1 of its electrons in the valence shell, and also carbons use the 1 of its electrons, right? Right? That's why that in O level we used to have these kinds of configuration. This used to be carbon, for instance, for this case. This is hydrogen. Are we together? Are we together? So homolytic bond cleavage, you say that when this bond between carbon and hydrogen has to break, right? Then what do you think? You think that hydrogen will leave its 1 electron that it has contributed, 1 electron that has contributed. Okay? Are we together? So if that's the case, here the dimension is CH3, because I'm lacking 1 electron. Here it is. Hence we say that plus what? Hydrogen, which is partially positive. But this one also, partially not partially negative. So we say that this is what? A free radical. Are we together? What does it mean? Hydrogens contain its electrons. This one message contains its electrons. All right. Are we together? Be careful of that concept because it's really confusing. In the next sessions, I'll teach you about what it means of these half arrows, full arrows, what do they mean. So let me explain to you There's another type. The second one, we call it heterolytic. Heterolytic bond cleavage. Heterolytic bond cleavage. What is heterolytic? Heterolytic bonding breaking. Say heterolytic bond cleavage. Say it is power. Right in your mind. So simply say that heterolytic bond cleavage is the test of the bond cleavage in which that when the bond breaks, one atom will leave with all the electrons which have been shared. That means of what heterolytic bond cleavage. So one atom will act like as if so you say that simply in the type of bond cleavage is a type of bond cleavage in which one of the bonding atom leaves with what? So this leaves with wall pair of bonding electrons. This wall pair leaves with wall electrons documented information of covalent bond. So this is the case of the bond cleavage or breakings in which one of the bonding atoms leaves with wall electrons, means leaves with wall electrons, wall pair of electrons, wall pair pairs of 40 electrons donated in the formations of 40, which has been used to form the covalent bond. Right? So she's left with all the lone pair, not lone pair, with all the electrons, all the electrons. Informations of covalent bond. So let me give you an example and end the session. Example, You can have CH3, CH, and then here we have hydrogen, hydrogen. Right? So this we call it what? Chlorot, chlorethane. Right? So chlorethane. And hence, we want it to react with bromine. We want to formulate bromo. So what's going on here? So you say that when this reaction takes place, it remains short. So just say CH3. Here we had a bond with chlorine, is it?
Yes.
Okay, so we had a bond with chlorine. So then what happens? Chlorine is more electronegative more than carbon. Right?
Yes.
So when a bond breaks, chlorine will withdraw all the electrons because they have shared 2 electrons. One carbon has been donated by carbon, 1 electron has been donated by the 1 valence electron has been donated by carbon, and the 1 valence electron has been donated by what? Chlorine, right? That's why you have 2 electrons here which will form covalent bond. So now when we break, this is more electronegative more than carbon. So that's why that we draw the error, the arrow like this way. So these carbons will become partially positive, right? Are we together? So then this is CH3, so you have what? Hydrogen, then you have hydrogen, then you have what? Partially positive, right? Partially positive means it's partial positive. Then you have chlorine. Chlorine now just gains electrons, you have partially negative, or you have negative molecule. So you've already broke the bonds. This is the heterolytic. Heterolytic is when that one of the atom which has formed the covalent bonds to another atom withdraw all the electrons which have been used in formations of 40. Formations of 40. Covalent bond. So this is all about bond breakings. I'll be repeating several times when I will be teaching you some other concepts. But these are the foundations, and you have to remember because we are going to do this business, okay, several times as well as we can. So this is homework 5. I know that every student is thanking God now. Okay, the simple question is, with aid of chemical reaction, explain types of food, organic reaction. That is, this is the end of this session, session 5. I thank God who have been with me during the preparations of this session. It's not one of the long session, but session 6, I give you a promise, it's going to be longer than this. Because I'll teach you about rules we have to follow on doing the mechanisms of the chemical reactions. So may God keep you safe so that we may meet, and I invite you in session 6 when I'll be teaching about the rules of breaking bonds and formating bonds in organic chemistry. So make sure that you subscribe onto our YouTube channel so that you can get notifications once we upload any new video. And make sure that you go through all the lectures, all the sessions which I've been teaching about organic chemistry, physical chemistry, general chemistry, and even some other topics. Make sure that you go through them so you try your level best to understand. And believe me that God is near, close to you, so He'll teach you and reveal you more than what I've taught you. This is the little, just a little break that I know. It doesn't mean that I've spoken everything that I know, but at least that is the small percentage that I know, which I believe that is going to help present and future generation. So I'd like to thank you for joining me, and stay connected. You keep on prayer. I'll be praying for you, and you have to pray for me, so that we may do this business and even think how we can solve real life problems. So may God bless you. Meet you in the session 6. See you.